Science Olympiad Class 9. Motion.
Motion. Introduction. We often perceive an object to be in motion when its position changes with time. However, there are situations where the motion is inferred through indirect evidences. An object may appear to be moving for one person and stationary for some others. Most motions are complex. Some objects may move in a straight line, others may take a circular path. Some may rotate, and a few others may vibrate. There may be situations involving a combination of these. Uniform motion. Consider an object moving along a straight line. Let it travel 5 meters in the first second, 5 meters more in the second second, 5 meters in the third second, and 5 meters in the fourth second. In this case, the object covers 5 meters in each second. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. The time interval in this motion should be small.
Motion along a straight line. The simplest type of motion is the motion of an object along a straight line. The motion of an object moving along a straight line with respect to the point of reference is called a linear motion. For example, motion of a vehicle on a ground, object falling freely under gravity, etc. Consider the motion of an object moving along a straight line. Distance. The distance traveled by an object is the actual length of the path covered by a moving object, irrespective of the direction it has traveled. Displacement. The shortest distance measured from the initial to the final position of an object in a particular direction is known as displacement.
Non-uniform motion. In our day-to-day life, we come across motions where they cover unequal distances in equal intervals of time. For example, when a car is moving on a crowded street or a person is jogging in a park. These are some instances of non-uniform motion.
Non-uniform motion. Consider an object moving along a straight line. In uniform motion along a given direction, the displacement is equal to the distance traveled. In day-to-day life, we normally come across the objects undergoing non-uniform motion. For example, a car moving on a road, objects freely falling under gravity, etc. Non-uniform motion. If an object covers unequal distances in equal intervals of time, then the object is said to be in non-uniform motion.
Speed with direction. When the velocity of the object changes at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Mathematically, V average is equal to U plus V by 2, where V average is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same units, that is m s to the power of -1 or m by s.
Velocity. The time rate of change of displacement of an object is called the velocity of an object. Speed is equal to distance traveled by time taken. Rate of change of velocity. In a non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. The change of velocity of an object is measured by a physical quantity known as acceleration. Acceleration. The time rate of change of velocity of an object is known as acceleration of an object. Acceleration is equal to change in velocity by time taken. A is equal to final velocity minus initial velocity by time taken. That is, A is equal to v minus u by t. Acceleration is a vector quantity. Measuring the rate of motion. Different objects may take different amounts of time to cover a given distance. Some may move fast and some may go very slowly. The rate which the object moves can be different. Speed. Speed is defined as the distance traveled by an object in unit time. Speed is equal to distance traveled divided by time taken. U is equal to S by T. Distance traveled has no direction, and so speed also has no direction. Thus, speed is a scalar quantity. Average speed. As an object moves, it often undergoes change in its speed. Since most of the objects undergo non-uniform motion, the rate of motion is usually measured in terms of average speed. For example, if a car is moving with a speed of 25 km per hour, it does not mean that the car is moving at this speed all the time. Average speed of an object is obtained by dividing the total distance traveled by the total time taken. Average speed is equal to total distance traveled by total time taken.
Distance. Time graphs. The change in the position of an object with time can be represented on the distance time graph adopting a convenient scale of choice. In this graph, time is taken along the x-axis and distance is taken along the y-axis. Distance time graphs can be employed under various conditions where objects move with uniform speed, non-uniform speed, remain at rest, etc. Velocity time graphs. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time graph will not change with time. It will be a straight line parallel to the x-axis.
To know the distance moved by the car between time t1 and t2, draw perpendiculars from the points corresponding to the time t1 and t2 on the graph. The velocity of 40 km per hour is represented by the height AC or BD, and the time t2 minus t1 is represented by the length AB. So, the distance is moved by the car in time t2 minus t1 can be expressed as shown below. Uniform acceleration. An object has a uniform acceleration if it travels in a straight line and its velocity changes in equal amounts in equal intervals of time. The motion of a freely falling body is an example for uniform acceleration motion. Graphical representation of motion. Graphs provide a convenient method to present basic information about a variety of events. To describe the motion of an object, line graphs can be used, which are generally used to solve the equations having two variables. In the case of motion, line graphs show dependence of one physical quantity, physical distance or velocity, on another quantity, time.
Equations of motion. Equations of motion are v is equal to u plus at. Equation 1, s is equal to ut plus half of at squared. Equation 2, 2as is equal to v squared minus u squared. Equation 3, where u is the initial velocity of the object which moves with uniform acceleration a for time t. V is the final velocity and s is the distance travelled by the object in time t. Equation 1 describes the velocity-time relation and equation 2 represents the position-time relation. Equation 3 represents the relation between the position and the velocity that can be obtained from equation 1 and equation 2 by eliminating t. These three equations can be derived by graphical method. Uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Take a piece of thread and tie a small piece of stone at one of its ends. Move the stone to describe a circular path with constant speed by holding the thread at the other end. Now, let the stone go by releasing the thread. By repeating the activity for a few times and releasing the stone at different positions of the circular path, check whether the direction in which the stone moves remains the same or not. If you carefully note, on being released, the stone moves along a straight line tangential to the circular path. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. This shows that the direction of motion changed at every point when the stone was moving along the circular path.
Motion sensors. The ultrasonic echo technique is used to determine the distance of an object from a sensor connecting a data logger and a computer, enabling a distance time graph to be plotted directly. Ticker tape timer. This enables us to measure speed and distance. From this data, we can estimate acceleration. It has a marker which vibrates at a certain frequency, 50 per second, and makes dots at 1/50th of every second on the paper tape, which is pulled through it. The distance between successive dots can be measured along with the time, and hence velocity can be estimated. Tape charts can be made by sticking successive strips of tape. Photographic timer. This is used to record the time taken for a trolley to pass through a gate.